السلام عليكم ورحمة الله وبركاته. احنا النهاردة هنتكلم عن second presentation of reactions. This example you are seeing is very nice in terms of being a little bit complicated. يعني هو مش معقد قوي بس يعني a little bit complicated. What we are having here is that member CD is actually more like a cable, and the beam ABC is hanged from it at point C partially and supported on the other side by B. So actually you could simply substructure this structure and deal with it in the following manner. So you will simply remove CD and place a force called VC, representing the vertical force at C. So, and the values will be very simple. So if you take a moment at B, you will be capable of calculating VC, which is, by the way, actually equal to VD. So now simply VC times 6, negative VC times 6 plus 15 times 8 times 2, which is the resultant force of the distributed load, minus 5 times 2, which is the concentrated load on the other side. All that is equal to 0. So now VC is 38.33. Now from equilibrium, sigma Fy is simply VB plus VC minus 5 minus 15 times 8. So that will give us VB equal to 86.67. And of course VD is equal to VC if we look at the equilibrium of member CD. Example 2, the beam ABC is supported by a hinge connection at A and a link member at point B. This member BD is hinged from point D2. So actually we have here 4 unknowns. Horizontal force at A and vertical force at A, horizontal force at D and vertical force at D. So we will use the conditional equation concept. So we'll have one additional equation, which is the additional moment at B. عندنا معادلة زيادة عند B. First thing, sigma moment about A equals 0. 2HD minus 15 times 4 minus 4 times 2 times 1 equals 0. HD equals 34 kilonewton. Of course, sigma Fx equals 0. 34 minus HA, where HA is equal to 34 kilonewton in the opposite direction. So in opposite to HD. Conditional equation, sigma moment about B equals 0. So simply 2 times 34 minus 2 VD equals 0. We are looking down. We are looking at member BD only. So 2 times 34, it's 2 times the horizontal action, minus 2 VD. So now VD equals 34 kilonewton up. Therefore, sigma Fy equals 0. So 34 plus HA minus 15 minus 4 times 2 equals 0. So now HA is 11 kilonewton down. In example 3, the truss CDEF is supported on the hinge E and resting on a roller at C that is resting on the cantilever ABC. So simply we will use the concept of substructure. So we'll take this truss, study the truss alone. Truss CDEF. simply sigma moment about C equals 0. So 120 times 4 minus 40 times 3 minus 8 VE equals 0. So VE equal 45 kilonewton. Sigma Fy equals 0. So VC minus 120 plus VE equals 0. So VC equal 75 kilonewton. And sigma Fx equals 0. He minus 40 equals 0. He equal 40 kilonewton. Then this force VC will be transferred to the cantilever, however in the opposite direction. So now sigma Fy equals 0, Va minus the 75 equals 0. So Va is equal to 75 kilonewton. Sigma m about A equals 0, so 75 times 8 minus the moment reaction at A equals 0, so Va is equal to 600 kilonewton meter as shown here.